While studying differential equations, I came across the pair of differential equations governing love dynamics. I got interested and I tried to unfold this for you. Let us go ahead and see how it can be represented and understood. The love-hate or love-love differential equations were first proposed by a mathematician, Stephen Strogatz, in 1980s to model the emotional interactions between two people, say Romeo and Juliet. Not a very justifiable combination because their love story ended in a tragic sense, but let us consider these notations. Each person's feelings change in response to their own emotions and others. We can model this as a system of first order differential equations. The first and the foremost question that pops in our mind is that can our mathematics represent the feelings of affection and disgust in form of equations? The answer is yes. A pair of differential equations can represent a love-hate or love-love relationship. Here you can see a pair of equation. R stands for Romeo's love and J stands for Juliet's love. So here this pair of equation we shall try to understand in the form R of t represents Romeo's affection with Juliet at any point of time t. So R of t is a function that depends on variable time, and J of t obviously represents Juliet's affection with Romeo at the given point of time. And d dt of R of t, I shall in short write R dot, a dot on the top of letter capital R, the rate of change of affection of Romeo, and J dot similarly represents the rate of change of affection of Juliet. So, in shorthand notation, the pair of differential equations we can write as R dot equal to A times R plus B times J, and J dot is equal to C times R plus D times J. Here A, B, C, D are four constants stating how each respond others. A represents Romeo's cautiousness, that is self-reinforcement or self-induced uh, approach to himself. So it can be cautiousness or internal feelings of love. So depending on that, A will be negative or positive. Cautiousness will lead A to negativity. The coefficient A will be positive if he has positive feelings, if he has attractive feelings for Juliet. Similarly, B represents the Romeo's response to Juliet's feelings. C represents Juliet's response to Romeo's feeling, and D represents Juliet's cautiousness about her own feelings. So here we are bound to deal with four constants. Dealing with four constants in our pair of equation will lead to mathematical complexity. To avoid that, we shall consider our modern Romeo and Juliet on equal footings in the sense that they are equally affectionate to each other, meaning thereby B is equal to C, and they are equally cautious to not fall in love, for example, meaning thereby A is equal to D. So, not disclosing that both are in love at first sight obviously the less probable nature of composite probability that can be ruled out. The cautiousness can be looked as equally modest approach, meaning thereby A is equal to D. This will simplify the equation solving considerably, and in our first attempt, making like footings, like-minded, identically groomed Romeo and Juliet, making equally cautious and equally modest with each other, will ensure that B is greater than 0, meaning thereby Romeo and Juliet are most equally affectionate but composed about each other, and A less than 0, meaning Romeo and Juliet are most equally modest respecting each other's personal space. So these restrictions will simplify a pair of constants, and the nature of A and B we have fixed. The considerations of approach has made our equation simple, and with this simplicity we shall delve into the calculations. A pair of differential equations governing equally affectionate but composed and almost equally cautious. Here we must note that A is negative because cautiousness is preventing love, and they are affectionate governed by the constant B that is positive. So R dot is equal to AR plus BJ, and J dot is equal to BR plus AJ. So this pair of differential equation can be meant into a matrix form as appearing on your screen, and here we have to deal with this matrix A. The trace of matrix I am calling tau, that will be twice A obviously, and twice A will be less than 0 because we have considered A to be negative. Similarly, delta I am denoting as determinant of A, which will be A square minus B square. Now here we shall try to evaluate eigenvalues of the matrix A, and the eigenvalues of matrix A will be lambda 1, lambda 2, that can be represented by the equation appearing on your screen, and if you substitute tau and delta, you will be able to conclude that lambda 1 will be A plus B and lambda 2 will be A minus B. Now here in this slide, we shall try to find out the eigenvector V bar associated with the matrix A we are dealing with. Let us suppose that this eigenvector V is xy, and we'll try to find out the value of x and y pertaining to lambda 1 first and then lambda 2, where lambda 1 and lambda 2 are eigenvalues of this matrix A, which is ABBA. Now, the equation that should be satisfied should be matrix A operated on eigenvector V yields eigenvalue lambda into the same vector field or vector V bar. So here you can operate a pair of equations, once for lambda 1 and second time for lambda 2. And on simplification, you will be able to conclude that x equal to y and y equal to minus x will be the two vectors leading to v1 represented by 1 1 and v2 represented by 1 minus 1. Let us try to locate into two dimensions how it behaves. v1 will be 1 1 and v2 will be 1 minus 1. So this is how we have established the eigenvectors v1 and v2 associated with the matrix A based on the lambda 1 and lambda 2. In our restricted situation, we shall deal with a case in which mod of A is greater than mod of B. That is, the magnitude of cautiousness is more than the response. In this situation, lambda 1 and lambda 2 both will be negative, and because of this, the romance fizzles and everything ends up in apathy. So, wheresoever love begins, it will end up into apathy, meaning thereby all will have similar end point going towards 0 0. That is, nothing happening, can say, substantial that governs the love lorn relationship in this way. So everything is ending up at the origin where the coordinates are 0 0. Now we shall deal with the second case wherein mod of B is greater than A, that is, the response is greater than cautiousness. A response given by Romeo to Juliet is more than the cautiousness which is holding their love affair. So in this situation, lambda 1 and lambda 2 you can work out, both will be positive. And in this situation, if the mutual love begins from above the vector v2, it will end up in love making. So here you can see, if anything is coming up above vector v2, then it will end up in a better love affair and romance. So if you start above v2 eigen direction, v1, v2 are actually eigen directions. Though we are calling them vector, we are not interested in magnitude. Their direction will then end up in mutual love. And how that will go up, it will be further governed by the situations they are facing. Below V2, I mean to say, if something is starting below V2, it will end up in hate, mutual hate. So in this direction, we are going towards hate, whereas here we are heading towards mutual love. Now we are into a Maple worksheet wherein we are going to handle this equation in a very elegant way. To begin with, I shall prefer A equal to D, both having negative value, say minus 0.2, minus 0.2. Whereas B and C, that is reciprocative feelings, those are positive. So consciousness is overpowered by the response of love feeling by each other, I mean Romeo and Juliet. So I am solving this differential equation, and here you can observe that this is origin of the coordinate system and everything is floating towards love, as referred to you in the last slide. Whereas if you want to have a look at complete spectrum wherein this is the point origin, and you can see that things above V2 will end up in love, whereas below V2 will end up in hate relationship. Now instead of having consciousness, a small consciousness, we shall begin with a situation where both of them have a positive reciprocative thing for each other, and this will lead in a better way towards their love relationship. But from the second chart, which is chanting the entire xy plane, in the sense that this is your x-axis and this one is y-axis, this being center. If you begin with eigen direction v2 above, then only they will be heading towards uh, endless love. Otherwise they may end up with hate relationship. When these guys are equally cautious and bearing a reciprocative positive love angle for each other, and they start with a vector above what you call v2, then the story goes towards love. So here you can see one follows another. On contrary, if you have a look at the entire spectrum with reference to origin, this is the origin, and in this reference, if you try to track this, it depends on starting point. If they start below v2, then they will be ending up towards hate relationship. Now we shall modify our plot for the situation that A is equal to 0, Romeo is careless, he is neither cautious about not pre-decided whether to fall in love with Juliet, no pre-feelings. In this situation, we begin our discussion, but D is equal to minus 0.8, that is, the cautiousness of Juliet is highest. In this situation also, the love making scenario will end up with a difficulty, indicating that the slope of this section is going towards 0. However, it depends on the starting point. In case they are starting below V2, then they may end up in hate situation. Now again I am exploring the same worksheet which we have developed here. Romeo is little bit cautious, but he has positive reciprocative feelings, and this time Juliet is not at all inclined. Her response is totally negative and her cautiousness is highest. Under this situation, what will happen? This is a very interesting practical situation. So here you can see the arrows going towards hate situation. And if you look at a complete spectrum of xy coordinates, this will be origin, and here in no sense we are going towards the love making. Everything is crumbling down towards origin. That is a singular point, nothing happening. We shall have a closer look at these differential equations, wherein we have differential equation 1, very simple, in the sense that the rate of change of love of Romeo is directly proportional to Juliet's state of mind, and vice versa, and we have a boundary condition which we require for eliminating constants, and you can see here the solution of differential equation that leads to kind of exponential function depending on the constants appearing in the form C1, C2, and it can be solved by numeric method, and we can generate a graph of r of t versus t, and similarly we can generate a graph of j of t versus t, and we can have a look at both of them. They are overlapping, being identical. Using Maple once we shall solve this differential equation that we have done in the PowerPoint presentation. We have this pair of equation and this command dsolve d1 d2 for r of t j of t. If we execute, you will be able to see the eigenvalues lambda 2, lambda 1, lambda 2, lambda 1 along with constants C1 and C2 uh, here appearing with positive signs and sign and here appearing with negative sign. Now if you want to have a look at the complicated equation which renders the behavior of Romeo and Juliet independently by constants A, B, C, and D instead of making them identical and simple, you will be able to see the solution of differential equation. This is how it goes. Now I want to comment on the behavior of constants. If A is greater than 0 and D is greater than 0, then the love grows easily from within. And if they are negative, the love fades out without active efforts. If B is positive or C is positive, then returns love with love. Whereas when B is negative or C is negative, the response by doing the opposite leads to a critical situation. Contrarian is a person who opposes or rejects the popular opinion, common beliefs, or majority current of thoughts. The term is often used to describe a person who takes an opposite view just for the sake of challenging the consensus. When our all involved coefficients A, B, C, D are positive, in this case, love grows exponentially, which mirrors the intense and dramatic escalation seen in Shakespeare's story. Whenever we encounter with a love-hate oscillating situation, which is a dramatic mode many a times we experience in our society, wherein Juliet can be considered to be contrarian. For generating this situation, A and D we are considering not affecting, whereas B is equal to minus C. Under this situation, the system produces endless oscillations about origin, and here the solutions are periodic. R of t represented by cosine function and j of t represented by sinusoidal function. For the similar condition A and D not affecting our equations, whereas B is equal to minus C, we have put some numerical value and we can solve this equation, and here you can see that it is depending on periodic functions. Similar condition we are using in the another worksheet where A and D is equal to 0, B is equal to minus C equal to 0.5, and here you can observe in the first quadrant the things are revolving about z-axis, and in this complete view with respect to this as origin you can observe that the continuous dramatic relation is going up. A nonlinear, more realistic drama can also be understood by incorporating new cubic terms which represent overthinking, emotional saturation, social pressure, and so on. You can bring in breach of trust and all things that leads to complication of differential equation. However, a general behavior can be understood by a simple equation. That was the objective of this lecture. I guess we have given sufficient time for understanding this pair of differential equation which is interdependent system and that is representing love-hate relationship. Thank you very much for your attention.